worlds of different dimension. The properties of four-dimensional space will become clearer if we compare three-dimensional space in detail with the two-dimensional surface, and then discover the differences existing between them. Hinton, in his book, A New Era of Thought, examines these differences, representing to himself two square-based pyramids, cut out of paper, the right angles of which are placed in opposite directions. These triangles will be equal, but for some reason, quite different. The right angle of one is directed to the right, while that of the other is to the left. If anyone wants to make them similar, it is possible to do so only with the help of three-dimensional space. That is, it is necessary to take one triangle, turn it over, and put it back onto the plane. Then they will be two equal and exactly similar triangles. However, in order to effect this, it was necessary to take one triangle from the plane and move it into three-dimensional space, then turn it over in that space. If the triangle is left on the plane, then it will never be possible to make it identical with the other, keeping the same relation of angles of one to those of the other. If the triangle is merely rotated in the plane, then this similarity will never be established. In our world there are figures quite analogous to these triangles. Hinton notes, we know certain shapes that are equal the one to the other, that are exactly similar and yet which we cannot make fit into the same portion of space, either practically or by imagination. If we look at our two hands we see this clearly, though the two hands represent a complex case of symmetrical similarity. There is only one way in which the right hand and the left hand may practically be brought into likeness. If we take a glove from our right hand and try to make it fit on the left or vice versa, they will not fit. Now suppose the same thing is done with the solid hand as can be done with a glove. When it is turned inside out, we may imagine it, so to speak, pulled through itself. If such an operation were possible, then the right hand would be an exact model of the left hand. Such an operation would be possible in higher dimensional space only, just as the overturning of the triangle is possible only in a space relatively higher than the plane. Even granting the existence of four-dimensional space, the turning of the hand inside out and pulling it through itself is a practical impossibility, on account of causes independent of geometric conditions. However, this does not diminish its value as an example. Things like the inversion of the hand are possible theoretically in four-dimensional space, because in this space different, and even distant points of our space and time touch, or at least have the possibility of contact. All points of a sheet of paper lying on a table are separated from one another. However, by lifting the sheet from the table, it becomes possible to fold it in such a way as to bring together any given points. If on one corner is written the word London and on the other corner the word Brisbane, then nothing prevents the placing together of these corners. Then, if on the third corner is written the year 1912 and on the fourth corner the year 2012, then these corners can touch one another too. If on the one corner the year is written in red ink and the ink has not yet dried, then the figures may imprint themselves upon the other corner. Again, if afterward, the sheet is straightened out and laid back on the table, then it will be absolutely incomprehensible to one who has not followed the operation, how the figure from one corner could transfer itself to another corner. For such an observer, the possibility of contact between remote points on a sheet of paper would be incomprehensible, and will remain incomprehensible, for as long as they think of the sheet of paper in two-dimensional space only. The moment they imagine the sheet in three-dimensional space, this possibility will become very real and obvious to them. In considering the relation of the fourth dimension to the three known to us, we must conclude that our geometry is obviously insufficient for the investigation of higher space. As previously stated, a four-dimensional body is as incommensurable with three-dimensional space as a span of 12 months is incommensurable with the city of New York. It is clear why this is so, because the four-dimensional body consists of an infinite number of three-dimensional bodies, and accordingly there cannot be a common measure for them. The three-dimensional body in comparison with the four-dimensional one is equivalent to the point in comparison with a line. Just as the point is incommensurable with the line, then so too is the line incommensurable with the surface, and the surface is incommensurable with the solid body. Thus too, is the three-dimensional body incommensurable with the four-dimensional one. It is also clear why the geometry of 3 dimensions is insufficient for the definition of position in the region of the 4th dimension in relation to 3-dimensional space. Just as in the geometry of 1 dimension, the line, it is impossible to define the position of the surface, the side of which constitutes the given line. Just as in the geometry of 2 dimensions, the surface, it is impossible to define the position of the solid, the side of which constitutes the surface. Then so too in the geometry of 3 dimensions, in 3-dimensional space, it is impossible to define a 4-dimensional space. As planimetry is insufficient for the investigating of the problems of stereometry, then so too is stereometry insufficient for the investigation of 4-dimensional space. Every point of our space is the section of a line in higher space, or as B. Riemann expressed it, the material atom is the entrance of the 4th dimension into 3-dimensional space. For a closer approach to the problem of higher dimensions and of higher space, it is necessary first to understand the constitution and properties of the higher dimensional region in comparison with the region of 3 dimensions. Then only will appear the possibility of a more exact investigation of this region and a classification of the laws governing it. What is it then that it is necessary to understand? It is first necessary to understand that we are considering not 2 regions spatially different from one another, and not 2 regions of which one, again spatially or geometrically, constitutes a part of the other, but 2 separate methods of receptivity of one and the same unique world, of a space that is unique. Furthermore, it is necessary to understand that all objects known to us exist not only in those categories in which they are perceived by us, but in an infinite number of others, in which we do not and cannot sense them. We must learn to first of all think of things in other categories and that, as far as we are able to, imagine them therein. Only after doing this, can we possibly develop the faculty to apprehend them in higher space, and to sense higher space itself. A series of analogies and comparisons are used for the definition of that which can be, and that which cannot be, in the region of higher dimensions. We imagine worlds of 1 and of 2 dimensions, then out of the relations of lower dimensional worlds to higher ones, we deduce possible relations of our world to one of 4 dimensions. Just as out of the relations of points to lines, of lines to surfaces and of surfaces to solids, we deduce the relations of our solids to 4-dimensional ones. Let's examine then everything that this method of analogy can yield, and imagine therefore a world of 1 dimension. It will be a line, and upon this line let us imagine living beings. Upon this line, which represents the universe for them, they will be able to move forward and backward only. These beings will be as points or segments on a line, and nothing will exist for them outside of their line. They will not be aware of the line upon which they are living and moving, for there will exist for them only 2 points, ahead and behind, or maybe just 1 point ahead. Humanity, such as they are, mostly function in this manner emotionally. They are 1-dimensional emotional beings, bipolar, fluctuating between hot and cold, angry or sad, elated or depressed. Noticing the change in state of these points, a 1-dimensional being will call these changes phenomena. If we suppose the line upon which the 1-dimensional being exists to be passing through the different objects of our world, then of all these objects the 1-dimensional being shall perceive 1 point only. Its point of view, or a worldview impacting only its existence. If different bodies intersect this line, then the 1-dimensional being will sense them only as the appearance, the more or less prolonged existence, and then disappearance, of a point. This appearance, existence and disappearance of a point will constitute for it phenomenon. Where emotionally, this is described as internal, considering the world as it affects me and nothing else. This is the life of the worm in us. Phenomena, according to the character and properties of passing objects, the velocities and properties of their motions, for the 1-dimensional being, will be either constant or variable, long or short-termed, periodic or random. The 1-dimensional being shall however be unable to understand or explain constancy or variability, the duration or brevity, the periodicity or randomness of phenomena of this world, and will regard these simply as the properties of such phenomena. The solids intersecting their line may be different, but for the 1-dimensional being, all phenomena will be absolutely identical, just the appearance or disappearance of a point. They will reflect to themselves, "This is always happening to me." Phenomena will therefore differ only in duration and in greater or less frequency. Such strange monotony and similarity of the diverse and heterogeneous phenomena of the world will be the characteristic peculiarity of this one-dimensional world. Furthermore, if we assume that the one-dimensional being possesses memory, then it is clear that in recalling all of the points seen by them as phenomena, they will refer them to time. The point which was, this is the phenomenon already non-existent. The point which may be, or appear tomorrow, this is the phenomenon which does not exist as yet. All of our space, with the exception of one line, will be in the category of time, i.e. something wherefrom phenomenon emerge and into which they disappear. The one-dimensional being will declare that the idea of time arises for them out of the observation of motion, that is to say, out of the appearance and disappearance of points. These will be considered as temporal phenomenon, beginning at that moment when they become visible, and ending, ceasing to exist, at that moment when they become invisible. The one-dimensional being will not be in a position to imagine that the phenomenon goes on existing somewhere else, though invisible to them, or they will imagine it as existing somewhere on their line, far ahead of them. We can imagine this one-dimensional being more vividly. Let us take an atom hovering in space, or simply a particle of dust, carried along by the air, and then imagine this atom or particle of dust as possessing a consciousness, i.e. separating itself from the outside world. Imagine that it is conscious only of that which lies in the line of its motion, and of that into which it comes into direct contact with. This particle will then be a one-dimensional being, in the full sense of the word. It can fly and move in all directions, however it will always seem that it is moving upon a single line. Outside of this line, or trajectory, will be for this particle, a great nothingness. The whole universe will appear to it, as only one line. It will feel none of the turns and angles of its trajectory, for to feel an angle, it is necessary to be conscious of that which lies to the right or to the left, above or below. In all other respects, such a being will be identical with the aforementioned creature living upon an imaginary line. Everything they come into contact with, everything they are conscious of, will seem to them to be emerging from time, i.e. from nothing, and then vanishing again into time, into nothing. This nothing will be the entire three-dimensional world, and our world, except for one line, will be called time. Counted as actually non-existent. Let us now consider the two-dimensional world, and the being living upon a plane. The universe of this being will be one great plane. Let us imagine beings on this plane having the shape of points, lines and flat geometrical figures. Egyptian hieroglyphs and artwork. The objects and solids of this world shall have the shape of flat geometrical figures. In what manner will a being living on such a plane universe cognize their world? First of all, we can affirm, they will not feel the plane upon which they live. They will not do so, because they will feel the objects, i.e. the figures, that are on this plane. They will feel the lines which limit them, and for this reason they will not feel their plane, for in that case they would not be in a position to discern the lines. The lines will differ from the plane, in that they produce sensations, therefore they exist. The plane does not produce sensations, and therefore it does not exist. Moving on the plane, the two-dimensional being, feeling no sensations, will declare that nothing now exists. After having encountered some figure, having sensed its lines, they will say that something appeared. However, gradually, by process of reasoning, the two-dimensional being will come to the conclusion that the figures they encounter exist on something, or in something. Thereupon they may name such a plane, not knowing indeed that it is a plane, the ether. Accordingly, they will declare that the ether fills all space, but differs in its quantities from matter. By matter, they will mean lines. Having come to this conclusion, the two-dimensional being will regard all processes as happening in this ether, i.e. in their space. They will not be in a position to imagine anything outside of this ether, that is, outside of their plane. If anything proceeding outside of their plane comes into contact with their consciousness, then they will either deny it, or regard it as something subjective, the creation of their own imagination. Otherwise they will believe that it is proceeding right on the plane, in the ether, as are all other phenomena. Sensing lines only, the plane being will not sense them as we do. Firstly, they will see no angle. It is easy for us to verify this by experiment. Hold before your eyes two matches, inclined one to the other in a horizontal plane, and you shall see only one line. To see the angle we shall have to look from above. The two-dimensional being cannot look from above, and therefore cannot see the angle. However, measuring the distance between the lines of different solids of their world, the two-dimensional being will come continually into contact with the angle, and regard it as a strange property of the line, which is sometimes manifest and sometimes not. They will refer the angle to time, and regard it as a temporary evanescent phenomenon, a change in the state of a solid, or as motion. The line moving away, and then coming back again as attempts are made to sense its properties. It may be difficult to regard the angle as motion, but this is correctly so, and cannot be otherwise. If we try to represent to ourselves how the plane being studies the square, then we shall find that for the plane being, the square will be a moving body. Let us imagine that the plane being is opposite one of the angles of the square. They do not see the angle. Before them is a line, but a line possessing very curious properties. Approaching this line, the two-dimensional being observes that a strange thing is happening to the line. One point remains in the same position, while other points are withdrawing back from both sides. The two-dimensional being has no idea of an angle. Apparently, the line remains the same as it was, yet something is happening to it without doubt. The plane being will say that the line is moving, but so rapidly as to be imperceptible to sight. If the plane being moves away from the angle, and follows along a side of the square, then the side will become immobile. But when they come to the angle, they will notice the motion again. After going around the square several times, they will establish the fact of regular periodic motions of the line. Quite probably in the mind of the plane being, the square will assume the form of a body possessing the properties of periodic motions, invisible to the eye, but possessing definite physical effects. Molecular motion, or it will remain there as a perception of periodic moments of rest and motion in one complex line. It may even seem to be a rotating body. The plane being will regard the angle as their own subjective perception, and will doubt whether any reality corresponds to this subjective perception. Nonetheless, they will reflect that if there is an action, yielding to measurement, then so too must there be a cause of this action, consisting of the change of state in the line, i.e. in motion. The line visible to the plane being, they may call matter, and the angles, motion. That is, they may call the broken line with an angle, moving matter. Truly to them, such a line by reason of its properties, will be analogous to matter in motion. If a cube were to rest upon the plane on which the plane being lies, then this cube will not exist for the two-dimensional being, but only the square face of the cube in contact with the plane will exist for them, as a line with periodic motions. Correspondingly, all other solids lying outside of their plane, in contact with it or passing through it, will not exist for the plane being. The planes of contact or cross-sections of these bodies will alone be sensed. However, if these planes or sections move or change, then the two-dimensional being will think that the cause of the change of motions lies in the bodies themselves, i.e. right there on the plane. As stated, the two-dimensional being will regard any straight lines only as immobile matter. Irregular lines and curves will seem to be moving. As far as really moving lines are concerned, that is, lines limiting the cross-sections or planes of contact passing through, moving along the plane, these will be for the two-dimensional being something inconceivable and incommensurable. It will be as though there were in them the presence of something independent, depending upon itself only, animated. This effect will proceed from two causes. They can measure the immobile angles and curves, the properties of which the two-dimensional being calls motion, for the reason that they are immobile. Moving figures, on the contrary, they cannot measure, because the change in them will be out of their control. These changes will depend upon the properties of the whole body, and its motions. Of that whole body the two-dimensional being will only know, and perceive, one side or section. Not perceiving the existence of this body, and contemplating the motion pertaining to the sides and sections, they will probably regard them as living beings. They will affirm that there is something in them which differentiates them from other bodies, vital energy, perhaps even soul. That something will be regarded as inconceivable, and really will be inconceivable to the two-dimensional being, because to them it is the result of an incomprehensible motion of inconceivable solids.